All right, folks, what we're going to look at today is we're going to look at something called autosomal linkage. And autosomal linkage is a topic that involves autosomes. Now, what are autosomes? Autosomes are chromosomes numbers 1 to 44. And your sex chromosomes are 45 and 46. So if you're a male, 45X, 46Y, and if you're a female, 45 would be X, and 46 would be an X. So autosomes are the body chromosomes, all the other chromosomes that are not sex chromosomes. An autosomal linkage just means that here's one of those chromosomes, and it has got two separate genes on it in two different loci. Okay, so they are linked, they're together. A and B are linked. So here we go. Here's the other chromatid. And here's a homologous pair. So if let's say that one here came from mum, this one comes from dad. Well, dad might have different alleles. In this case, the recessive allele. So the genotype of this individual is still capital A, capital B, little b. But the A and the B are located on the same chromosome. Okay, they're on the same chromosome. Now, if it's not autosomal linkage, the question will say that the genes are on separate chromosomes. And this is everything that you've looked at up to now. So here's a homologous pair with the A. And here's a different homologous pair with the B. The genotype is still exactly the same because you've got an A and you've got a B. So the genotype is still capital A, capital B, little b. But what you've got here is A and B are not linked. They're on separate chromosomes. So when you work out the gametes, you have to work out every possible combination. So that A could be with a capital B, but that capital A could go with a little b into the gamete. That little a could go with the capital B into a gamete, and that little a could go with a little b into that gamete. So you have four potential gametes when they are on separate chromosomes. But with linkage, what you have is you reduce the variation in your gametes. Because they're on the same chromatid, then they're inherited together. So the only types of gametes you will get are these. Okay? So you're only getting two types of gametes. Capital A, capital B, little a, little b. Whereas in non-linkage, you will have four types. That's how we do hills and valleys. And we work out all the combinations of the gametes. Now, our topic we're looking at isn't them being on separate chromosomes, but it's actually being on the same chromosome. So we're calling it linkage, autosomal linkage. Now, can you see these homologous chromosomes are lined up very close together? So what might happen is you might get crossing over. Now, if crossing over occurs, let's just draw crossing over. So here's our A and B and our little a and b. Can you see? They've got so close to each other, they've entwined with each other. So there is the formation of a chiasmata. It's a structure where the overlapping of the chromatids occurs. Now they get pulled apart in meiosis 1 and then pulled apart again in meiosis 2. So what now are the combinations of the gametes? Well, can you see this one hasn't changed? This will still be capital A, capital B, and this one will still be little a, little b. We call these the parental types, and you get lots of them because they have not changed. But what has changed are these, because the capital A has joined with a little bit of that little b, and it's formed a recombinant gamete. Now, crossing over is rare, it's random, it doesn't always occur, so there is not going to be a lot of that gamete. And the other gamete you will find is the little a joining on with the capital B. So both of these are recombinant gametes. They're formed as a result of crossing over. The recombinant gametes are formed due to meiosis as a result of crossing over having occurred in meiosis 1. Okay. So crossing over leads to the swapping of the alleles, but then when you go through meiosis 1 and 2, then that will lead to the formation of recombinant gametes. So it's evidence that crossing over has occurred. But these are your two main types of gametes. Now, this affects the ratios of the individuals you produce because predominantly you get these gametes. So if we were going to do a cross between these two individuals, and it wasn't autosomal linkage, you would expect 9 of those, 3 of those, 3 of those. That's assuming that the A and the B gene are on separate chromosomes. But when they're on the same chromosome, it affects the ratio because you haven't got 4 gametes. You've not got equal amounts of these gametes. These gametes are produced as a result of the fact that the A and the B are on separate chromosomes. This isn't the case anymore with linkage. With linkage, the A and the B are on the same chromosomes. So we only have these two types of gametes, but a very few of these gametes. Now, if we put these gametes then together and across, so here's our parental type, you would find that the majority of the offspring in a ratio of 3 to 1 would be capital A with a capital B. And there's only one little a, little b. So if crossing over hadn't occurred, this would be the product. But we have got the small number of recombinants. So let's just cross them and add them to the mix. Now we haven't got a lot of these. So if they come together, we get a new combination. We haven't had a capital A with a little b before. No, we haven't had a capital A with a little b. Capital A with 2 little b. We've had one of them. We've had one of them. But we've not had one of these. See, we've not had one of them. So the ones I've underlined are offspring that will only be produced if two recombinant gametes fertilize, and there won't be many of them. Why won't there be many of them? Because there wasn't many recombinant gametes in the first place. They're produced as a result of crossing over. The main gametes are this one and this one because they're on the same chromosome. And when they get together, you get a ratio of 3:1. So what you find in autosomal linkage questions is you'll get an awful lot of these. And you'll get a reasonable amount of these. But then you'll get very few amounts of the new combinations. This one and this one. So the offspring could look like this: 900, 300, because it's a ratio of 3:1, and maybe 12, 7. You're thinking, hang on, these are really low in number. They're really low in number because these offspring have been produced with recombinant gametes. And there's not many of them. Why is there not many of them? Because recombinant gametes are produced as a result of crossing. I look forward to having a go at some questions on autosomal linkage, but that is the reason why we don't get a lovely 9:3 to 3:1 ratio, because the A and the Bs are not on different chromosomes anymore. Everything we've done in genetics up to now, the A and the B is on different chromosomes. So you produce all these different types of gametes. But with autosomal linkage, the A and the B are now on the same chromosome. So they're inherited together. The A and the B, capital A, capital B, little b, are inherited together. So you get lots of these two types of gametes. However, you know that happens randomly. Every now and again, you will get crossing over occurring. And because of crossing over, it switches up the combinations of the alleles. That's what recombination means. You're getting a different combination of alleles produced because of crossing over. The capital B is now joining on to the chromatid that has got little a on it, and the little b is joining on to the chromatid that has the capital A on it. So we're getting a different combination of gametes. I hope this has been useful, and I would watch the video again a few times until you get it, but always look out for large number of offspring in two of the characteristics of the offspring, and then a very small number of offspring in two of the characteristics. Okay? Because that indicates that those two that have been produced in very small number are due to fertilization of recombinant gametes. And recombinant gametes are produced by meiosis as a result of crossing over. I hope that's been really useful to you, and look forward to catching up with you soon. Cheers now, folks.